All right. Yesterday you had a worksheet to do. Today I'm just going to take a minute, kind of walk through the answers so you can check over your work. Now I started off with this one. It asked me to graph these two equations. I'm going to start by graphing 2x minus 10, and I'll graph that one in red. The y-intercept is negative 10, so I go down to negative 10. That's my first dot. After that, the slope, the 2, tells me it's going to go up 2 over 1. Now, I don't have to do all the dots. I could easily just do a line, and I'll see everywhere that line goes. I'll do the next one in blue. That's the y equals negative 4x plus 8. So I'll start at a y-intercept plus 8, positive 8. And the slope's a negative 4, or negative 4 over 1. So it's going to go down 4 over 1. Get a couple points, draw a line. And once I have that line done, finding the solution to them is pretty easy. It's the point where they cross. And it looks like that point is at 3, and then it's down 1, 2, 3, 4. So it's 3, negative 4. But I just can't assume that. I have to test to see if 3, negative 4 is the answer. And I'm going to do that by plugging in 3 into each equation. 2 times 3 minus 10 is negative 4. Works for the first one. For the second one, negative 4 times 3 is negative 12, plus 8 gives me negative 4. Also works for the second one. It is a solution to both equations. Number 2 is very similar. So once again, I'll take a look at the first equation. I'll do that one in red. It's going to be a negative 8 is the y-intercept. The slope is 3, so that's up 3 over 1, and then make a line. For the second one, y equals 2/3 x plus 6. I have to find the y-intercept of 6. And then it goes up 2 over 3. Make a line. And there's my answer. Looks like this is the point where they both cross. So the x number is 6. The y number looks to be up at 10. So I have 6, 10 is the coordinate pair. Plug in 6 into both equations, make sure that it actually works. And in the first equation, 3 times 6, 18, minus 8 is 10. And in the second one, 2/3 of 6, that's going to be 4, plus 6 more, still 10. So my answer is 6, 10. Now, I've worked through the first two pretty methodically. I've shown you how I've graphed each one. For the next couple, I'm just going to quickly skip through that part. I'm going to assume you know how to graph it. So I'm going to graph the two lines. And now I just have to find where do they cross. They cross right here at the point negative 3, comma 2. I'm going to plug negative 3 in for x into that top equation. 2 times negative 3, that's negative 6, plus 8 gives me 2. That works. Plug it into that second equation. 1/3 of negative 3, it's negative 1, plus 3 is 2. That is the solution to both lines. For number 4, do the same thing. Graph each of the two lines and look to see where they cross. That looks like it's right here, and that is the point 4, negative 5. So, as before, make sure it works. Plug in the x coordinate into both of them. Half of 4, that's 2, minus 7 is negative 5. Works for the red equation. Plug it in for the next one. Negative 3 times 4 is negative 12, plus 7 is also negative 5. This is the solution to the system of equations. This one is where it probably slowed down for you a little bit. And the reason is this first equation isn't in slope-intercept form. It's in standard form. Now, as we looked at last week, the quick and easy way to figure out standard form and to make a graph is just find the intercepts by plugging 0 in for x and 0 in for y. I'm going to do that. If I plug 0 in for x, I'm left with negative y equals negative 4, which means y is 4. And if I look at it the other way, and I plug 0 in for y, 2x equals negative 4. X is negative 2. Now, I just need to graph that. I put my 2 dots on the graph, then draw a line. The second equation, that's a little simpler. That's slope-intercept form. I have a y-intercept, just like I've been doing, that I can put on a graph, go down 3 and over 1, and then make the line. When I do that, the point of intersection is easy to find. It's at negative 1, 2, and I have to plug it in. I'm going to start by plugging it into the bottom one, the blue one, just because that's a little easier. Negative 3 times negative 1 is 3, minus 1 is 2. To plug it into that top equation, the 2x minus y equals negative 4, well, instead of x, it's negative 1. Instead of minus y, it's going to be minus 2, and it has to equal negative 4. So let's see if that happens. 2 times negative 1 is negative 2 minus 2. Does that equal negative 4? And it does. It's the solution. Now I have 2 equations. Both of them happen to be in standard form. So it's going to be a lot of finding intercepts. Starting off with the first one, plug 0 in for each one. When I plug 0 in for x, y is 8. And now I have to plug 0 in for y. When I do that, 2x equals 8, so x must be 4. I have 2 points I can put on my graph. Those are the x-intercept and the y-intercept, and I make a line. I'm going to do the same thing for the second equation. Plug 0 in for each. When I plug 0 in for x, I get negative y equals negative 2, so y must be 2. And repeating the process, when I put 0 in for y, I get x is negative 2. As before, I put the dots on my graph and make a line. The point of intersection, pretty easy to find. It looks like it's going to be 2, 4. It's just a matter of plugging it in and seeing if it works. For the red equation, it would be 2 times 2 plus 4 equals 8, which I know is true. And for the blue equation, that one's going to be 2 minus 4 equals negative 2. That's also true. I have my solution. I've double-checked it. I know we spent a lot of time reviewing this worksheet. That's for a good reason. You are welcome to go back, revise, and resubmit if you would like. Otherwise, hopefully you're doing well on this. As always, if you need help, please contact me. Send me a message on Schoology, however you want to get up with me, and I'll help you out with this. Good luck, guys.